This video will demonstrate the strategy design pattern. You can use this pattern when you want to perform a function, but you have several different ways that you could perform that function. Using a non-computer example, let's say I want to eat dinner. There are several ways I can accomplish that. I can go to my kitchen and cook dinner. I can go to a restaurant. I can call a place to deliver food to me. All of those different ways accomplish the function of getting me dinner, but they do it different ways. Those different ways are the strategies. For this example, I'll use a calculator class that's going to calculate an average of a list of numbers. But I want to be able to calculate the average by getting the mean average or by getting the median average. Those are my two different techniques or my two different strategies to accomplish the calculate average function. Here's one way you might do this without using the design pattern. You could have the calculator class with two different functions. Calculate average by mean that takes a list of numbers and returns the mean average, and another function, calculate average by median, that takes a list of values and returns the median average value. Another way you might do this without using the strategy design pattern is to have a calculator class with an enum for the different averaging methods, mean and median, and you have one calculate average function that takes a list of the values and takes a parameter that tells which averaging method to use. Then the function has a switch statement. If you passed in the mean as the averaging method, it calculates the average by the mean. If you passed in median for the averaging method parameter, it calculates the average using the median technique. Both of these non-pattern methods work fine, but you can run into a problem when you've got 20 different ways you want to do this, or if the code for each technique is 30, 40, 50 lines, then your function can suddenly be hundreds of lines long. Or if you use the first method, your calculator class has 20 or 30 different methods that do basically the same thing. Using the strategy design pattern, your code might be a little cleaner. However, it is a little more complex. You do have a few more parts that you have to set up. In this example, we're going to go from the one class in the non-strategy methods to 3 classes and an interface file. The first file we have is the interface. This declares what has to exist in our strategy classes. In this case, it has to have an average for method that takes a list of doubles and returns a double. For our concrete strategy classes, these are the classes that actually implement this interface. They all have to do this. Our first concrete strategy class is average by mean. It implements the iAveraging method interface, and it has a method average for that takes a list of values and returns a double. So it meets the criteria for the iAveraging method interface. Then we have another class, average by median. This also implements the iAveraging method interface, and it has the code here to calculate the average using the median method. So now we go to our calculator class. This version of the calculator class has a single function, calculate average for, then the list of values. It accepts an averaging method parameter, and the data type for that is iAveraging method. So it's any class that implements the iAveraging method interface, which would be our concrete strategy classes, the average by mean and the average by median. Then the calculate average for function here uses the average for function on the concrete strategy, passing in the values. So let's take a look at how this would be used. This is a unit test class that I use to test the code. When I want to calculate the average using the mean method, I instantiate a calculator object. I call the calculate average for method on that with my list of values, these numbers up here, and I pass in a new average by mean object. This would go to the calculator's calculate average for the numbers with my average by mean object. Then it's going to use the average for method on my average by mean object, pass in those values. The average for function on this concrete strategy class will calculate the average, return that, and the calculator's method here will return that value. If I want to calculate using the median method, it's the same type of code, but now I pass in a new average by median object. So when you call the calculator's calculate average for method, it will use this object, the average by median, to calculate the average. In case you're wondering about this, results are close enough. That's because we're dealing with floating point math, so the numbers could be a little bit off. And I have this little function down here that just says if we're good out to 5 decimal places, we're going to call that equal. For this simple example, the strategy design pattern is a little bit of overkill. It takes you some extra work and you don't really get any extra benefits out of it. But it can be useful if you have several different techniques or strategies that you want your function to use, or if you can reuse your concrete strategy classes. One place where I found this useful is when I need to validate a business object, but I need to validate it using different techniques. Let's say we have an order object that we want to validate, but I need to use a completely different set of rules to validate objects that are going to be shipped overseas, or if there might be something special about the order. Sometimes a specific item has to be shipped overnight. The indicators I would look for in code is if you have a class with several methods that are calculate using method A, calculate using method B, calculate using method C, or if you have one big calculate method with 10, 15, 20 switch statements or ifs and else ifs. That's an indicator that the strategy design pattern might be a good thing to use there. You might have noticed that this design pattern looks similar to the command design pattern. They're both examples of dependency inversion, which is sometimes called dependency injection or inversion of control. This is also an example of the idea of composition over inheritance. I'll create 2 more videos soon to show examples of dependency inversion and composition over inheritance, so you can get a little bit better idea of when to use them and what the benefits are. If you have any questions or comments about this design pattern, please leave a comment below. Thanks.